Dear learners, today we are going to study the unit number 6, input-output from the operating systems. After going through this unit, you will be able to understand the principles of input-output hardware, understand the principles of input-output software, and to familiarize the concept of DMA and disk scheduling. First, you have to understand the hardware, that is a hard disk. Disk comes in a separate shapes and sizes. The hard disk is a stack of magnetic surfaces. Data is written on the surfaces permanently except the first surface and the last surface. Surfaces are divided into the tracks and sectors. All surfaces have the same number of tracks. The tracks are divided into the sectors. The sum of all the tracks at a fixed distance from the edge of the disk is called a cylinder. All the sectors are of the same size. Time required reading and writing each sector is the same. Each surface is having separate read-write heads known as an arm assembly. All surfaces are rotated with the high speed in clockwise direction at a time. An arm assembly is moving in and out of the surface to read and write the data. To read and write the data, system provides three addresses, that is surface number, track number, and sector number. This is the diagram of the hard disk. You clearly understand from this diagram that there is a stack of the surfaces. First and last surface may not be used for the reading and writing. Other surfaces are used for the storage of the data. In between, there is a rod that is known as a spindle. This is arm assembly. That is the read-write heads are there with the arm assembly. It is moving in and out when you are reading or writing the data on the surfaces. When you want to read or write the data, the total time required is shown in the formula. Total read-write time is equal to data transfer time plus seek time plus latency time. The seek time is the time required to move arm assembly from one track to the another track. Suppose the arm assembly is on the track number 10, and if you want to move it to the track number 90. So whatever the time required to move from the track number 10 to the track number 90 is known as a seek time. Latency time is the time required to move the desired track sector. That we are on the sector number 10, and if you want to move the sector number 30, so time required to move from the sector number 10 to the sector number 30 is the latency time. There are various disk arm scheduling algorithms. The disk is shared resource. The following disk arm scheduling algorithms are used to reduce the seek time during the read-write operation. First come, first serve, shortest seek time first, and scan scheduling. First, we study the first come, first serve algorithm. This is the simplest disk scheduling technique. Here, requests are served in the sequence as received in the system. Here, no recording of the queue takes place. Here, no reordering of the queue takes place. In this technique, seek time is too much because our assembly is moving in and out as per the request sequentially. For example, consider the hard disk with the 150 tracks, and currently the head is on the track number 50 and moving outside. Following request queue received in the system to serve 50, 91, 150, 42, 130, 18, 140, 70, and 60. Calculate the total track movements and time required to move all these tracks. Consider seek time is equal to 0.25 seconds using FCFS. So this is a chart. This is the diagram. This is Gantt chart that we are drawing. If you see currently we are serving the track number 50 and we are moving to the other tracks. So we are currently on the track number 50. Then we are moving to the track number 91. Then we are moving to the track number 150. From 150 we are moving to the 42. From 42 we are moving to the 130. From 130 we are moving to the 80. From the 18 we are moving to the 140. 140 we are moving to 70. And from 70 we are moving to the 60. So total track movements in this case 41 plus 59 plus 108 plus 88 plus 112 plus 112 plus 70 plus 10. So total track movements are 610. So time required to move all these tracks is equal to total track moments into the seek time. So 610 multiplied by 0.25 second is equal to 152.5 seconds. So total head moments are 610 cylinders, and the total time required to move all these cylinders is 152.5 seconds. Second, that is shortest seek time first scheduling. The basic idea behind the algorithm is serve all the requests close to the current head position, that is with minimum seek time first. For example, consider the hard disk with 150 tracks, and currently the head is on the track number 50 and moving outside. Following request queues received in a system to serve 50, 91, 150, 42, 130, 18, 140, 70, and 60. Calculate the total track movements and the time required to move all these tracks. Consider seek time is equal to 0.25 seconds. In the above example, the cylinder close to the head position, that is 50, is 42. Next closest cylinder is 60. From there, the closest one is 70, then 91, then 130, then 140, then 150, and then finally go to the cylinder number 80. So if you see, we are moving from 50 to the 42, 42 to 60, 60 to 70, 70 to the 91, 91 to the 130, 130 to 140, 140 to 150, and after 150, we are moving to the cylinder number 18. So total track moments in this case, 8 plus 18 plus 10 plus 21 plus 39 plus 10 plus 10 plus 132, that is total 248 tracks. Total time required to move all these tracks is equal to total track moments into the seek time, that is 248 into 0.25 seconds, that is 62 seconds are required. So this scheme has reduced the total head moments to 248 cylinders and time to the 62 seconds. It is a quiz time. The sum of all the tracks at the fixed distance from the edge of the disk is called dash dash. The dash dash is the time required to move arm assembly from one track to the another track. The dash dash is the time required to move the desired sector. Dash dash algorithm serves all the requests close to the current head position, and hard disk surface are divided into the tracks and dash dash. And thus, the sum of all the tracks at a fixed distance from the edge of the disk is called cylinder. The seek time is the time required to move arm assembly from one track to the another track. The latency time is the time required to move the desired sector. Shortest seek time first algorithm serves all the requests close to the current head position, and surfaces are divided into the tracks and sectors. These are the references. Thank you very much. Today we'll stop here. Thank you.